Yeah.
Hi Raneesh, hi Ahmed.
Hi, Raj.
Ahmed.
Hi, Raneesh.
All right. Okay, so just basically aim of sort of have a bit of a talk today is obviously Edge, right? Edge HPC, Edge AI, and obviously the challenges and obviously the differences that you have when you're doing a normal data center. So, I mean, I suppose if I ask you both a question, what in terms of percentage difference between a normal data center and a HPC, Manish, what is the percentage difference, do you think?
So if you ask me, I will say 50 to 60% difference would be.
It's quite significant.
Yes,
Yeah.
significant. In terms of hardware, the software running for HPC over a traditional data center.
And I guess with a lot of HPC, I suppose there are newer applications as well.
Yes.
And you've been allocating those obviously onto the data center mine that you're working on.
Yes.
And so how do you go about looking at those applications? Because there's not many of them. So what sort of workloads, what does a workload look like?
Okay, so basically, as your name suggests, HPC runs for high performance for computing. Okay, so it is optimized for running parallel processing.
Right.
So what a lot of computer intensive workloads such as weather forecasting, simulations and everything. So it uses specialized software like MP, okay, or OpenMP or MPI
Right.
for that. So and mostly currently we are using NVIDIA GPUs for the parallel processing. So in future we'll have AMDs also.
Right.
Okay, so from NVIDIA we have different kind of libraries application like Omniverse and different like MetaLabs. So we use for simulation.
So that's a good point. So obviously, like a lot of people are saying they're using public cloud for HPC, but from what you're sounding like, there's more of a custom approach,
Yes.
right? So if I come with a workload, you're basically saying, okay, there's sequential processing, or there might be parallel processing, or try both.
Yes.
Right. So it depends on the use case. So that's obviously from a usage perspective. So that's interesting, which I'll come back to in a moment. So going back to the actual, like I say, the differences, right? So normal DCs, normal data centers, obviously they do put them in smaller locations, but there's always an economies of scale to have, right? So that's important. With Edge, obviously there's different economies of scale. So one could argue, as we've said, obviously the way the market is going as well, with obviously some of the applications we're talking about, you have to put these edge nodes in different places.
Yes.
So if you had to see a site today, and like obviously you've dealt with the one in SRTIP, would you be able to, by looking at the site, be
Yeah.
able to?
Yeah, of course. Actually, for new data centers, we have to look for the facilities which we are expecting from them in terms of power, in terms of location, physical security, accessing to the data center itself. This actually are a challenge which we have to plan for it. We have to look into it first. Like for example, because for HPC it's required power. Not all locations or all data center have enough power for HPC, so we have to look into it. Another one also in terms of security, physical security for the data center, it has to be more secure. In terms of other facilities, if we need to add our polling units, where we keep our polling units, this is we have to look into it.
Right.
Like what Ahmed said, power and cooling are two most important challenges we will be facing. So basically, first we need to set up an edge HPC. The first thing we have to look for is the power.
Right.
That's the moment, because all these GPUs and this consume a lot of power. So we have to first, what is our current need, what is our future requirement, how the facility can provide us in future.
Right.
So we have to look at that. Then we can bring in the experts like DCT, American, and everything. And for the further.
So once you've actually had a look at that site, you're able to design it out. That's good. But then also so if you have, let's say it comes back to architecture, right? Obviously now an edge architecture as opposed to a hyperscale data center are two separate things, right?
Yes.
That's where the major changes as well. And maybe the application will change that as well. So, okay, so you talked about architecture and future planning. So how do you plan for the future? If you have this building where there's a limited space for data center. Obviously there's space around the back, we know. But let's say you have a city center, you have a hotel, or you have a gas station, which are good places for an edge node.
Yes.
How do you then architecture for the second, third one? How do you get economies of scale? Have you thought of that?
Yes, of course, because the advantage of edge node is you can place it in anywhere, and we can connect with a 5G network.
Right.
So it's very easy. We need a small space. Okay, we can use petrol pumps, city center, any cafes where we can have different edge on different end. It can be collaborate together, and at the end it can talk to the main HPC. So I don't think space is something. It's a constraint for an.
Right.
Yeah.
Okay. So space, the agility is
Yeah,
there
agility.
in obviously how this works, and I guess the application will drive that. So when you talk about obviously the workload and the different softwares, and also you have the edge nodes. Have you thought about, or have you spoken to anyone about the type of customer that's going to use it, or is that something you haven't thought about yourself?
Like mostly, for an HPC, mostly we can have different universities. They have different,
HPC workloads,
Yes,
right?
HPC workloads.
Yeah.
Okay, the main bottleneck for them is to have the compute power.
Right.
So they can use the HPC, okay, and then they can test their ideas, and they can need to.
Right.
And then we have university, then they have research facilities, then law enforcement, then because they need to run process data, and they need huge computing power, and they need it live.
Right.
Okay, so and then scientific application, like they need to simulate things. So
So some static applications where someone will give you the data, you can run the data, and then secondary will be when you need to have live and it has to have real time.
That we cannot achieve through a traditional data center. We can achieve through a HPC.
It can use also in forecast modeling as well. Forecast modeling,
right?
Where we will have historical data, where we can do modeling, we can do expectation what's going on for the weather for the next days, which can be also used here. Can be used also in healthcare or financial modeling as well. For example, if I have online portal where is the customer or purchasing items.
Right.
For example, if I'm here in Gulf area, what is the most items they are purchasing? If I am in UK or if I am in Europe, what is the customer purchasing from there as well? This also can be utilized. You can use HPC and the AI models for this one.
Right. Okay, that's good. So that's the customer modeling. Obviously, is a good one for governments and retail as well. And I guess now the software applications are changing, right? So the existing, so that goes back to the original data center versus HPC data center. The data center applications that you have now, they're not going to transfer to HPC, are they?
Of course not.
No. So how will a traditional application, do they have a benefit of going to HPC?
So
just your thoughts on this.
So like usually the traditional data center, still people, there is a scope for it. There are a lot of business applications, traditional application running databases, website, application which doesn't need much of a more computing power. So the thing which the need is reliability and the backup over. So still, the traditional data center, there's a scope in this one. Okay, and they can scalable to an HPC because at the end, if they have the infrastructure, means the backend infrastructure ready, they can scale up to HPC. So it can coexist together. So you can run HPC workload on this one and then the traditional this one.
So there's a hybrid model there.
Hybrid model. So to add to Raneesh's point here, actually for traditional center we are using virtualization. But in HPC we are using Open MP and MPI.
Right.
where we can do parallel processing for our workloads. Another difference also, Raneesh, which is networking, which is connectivity between a cluster or servers.
Right.
In traditional data center, you are usually using Ethernet protocols, let's like 10 gigabit, which 10 gig, maximum 10 gig, 25 gig.
Right.
But in HPC, you are using either we are using HDR, InfiniBand HDR or Omnibus. There is all Omnibus, which is reaching up to 200 gig, and sometimes also there is available switches which is reaching 800 gig.
Right.
Okay, this latest, the latest NVIDIA GPU support 800 GB per second data transfer. So in order to accommodate that much speed, we need to have infrastructure, network devices.
It should be ready for this one.
Yeah, so basically HPC workload needs throughput.
Right.
Here actually for both of them, traditional data center and HPC, all of them here is server, storage, networking. But the difference between here, what is the hardware required for HPC, what is hardware required for server required for traditional data center is different. If I go down for storage, it will be also same because traditional data center doesn't need too much storage, but in HPC, of course, we need much storage. For networking, that's the same, as we said, 10 gig, maximum 25 gig. But in HPC, it needs 200 gig, sometimes reaching up to 200 gig.
Right. Okay. That's quite a difference.
Of course.
That's quite a difference. So so obviously I know you're talking to developers now. So they're in-house. You have Michael. Obviously they're externally start talking to developers. So you're able now to also then say, again, a traditional cloud, even though Google Cloud has a fixed sort of a fixed shopping list.
Yes.
Right, sort of things, and you have your traditional data center as well. So you can run a HPC in the cloud and a Google Cloud and a traditional data center. But to get a proper application, or maybe to get, let's say, localized application where you need that fast data, whether it be autonomous vehicles, autonomous cars, architecturally is going to be based on what the local environment is like as well, right?
Yes.
That's basically what you're saying as well. So are you working with software people as well?
Yes, we are collaborating with our product development team to make sure that there's a seamless processing.
So what sort of questions are they asking? Or what sort of advice do you give? Or what ideas do you give?
Usually, look, because when we develop a product, okay, so basically first thing, what type of hardware, how much hardware we need, right? Nobody can predict initially. So first we have to do is we will start with the basic.
Right.
We'll start with one node or one server, then see how much is the result. Then we scale up, right? Then we can get a point where we can have an optimized requirement, hardware requirement, and then based on the data and this, we can.
So it's similar to when on a traditional cloud. If you release your application, there's a spike in the cloud. You utilize more cloud. Here, you're utilizing HPC. You like you say, you might use 5 nodes.
Yes.
But then actually realize you only need 3 nodes.
3 nodes, yeah.
By modeling that compute, you're able to optimize
Yes.
what you need. Okay, that's interesting as well. And I suppose using those metrics, you're then able to design. If you're scaling to the city or scaling to a country, you can then scale a lot more effectively.
Yeah. So then we can have the edge AI can be configured properly.
Right. So that modeling is a key part. Okay. So in terms of obviously you're then obviously now you are edge AI experts in a way, right? Obviously you know the traditional data center, you know the edge AI side of things. Obviously the power and cooling, like you say, is they're not new methods of doing stuff, right? They're traditional. They've been used before. But I guess in terms of, like you say, the modular side, the modular way that this is done, right? So you now have an edge, obviously Mahir, you have an edge capability. You can add to that in the same space, or you can add to Mahir in another location. That's basically what you're saying, isn't it?
So we can do both.
You can do both, right? But then, would you also connect to public cloud? That's what you're saying as well, isn't it? If you have some data on the public cloud, and from what you're saying, 200, 400, 500 gigabits a second. If you've got multiple public cloud data, you can send it all one time.
Yes.
Right?
It depends on the
modeling, sorry. No, so what you would do is, so if you've got multiple, so if you're a big retailer, your end of week sales data,
Yeah.
you send it all one time
Yes.
into the data center, and then when you do your processing, you're able to send data like it, simulate it like it is it's coming in real time, and you have the capability to do video, metadata, everything, right? At one time, and that's why it gives it the capability. Yeah, no. And then on the processor side, so going back to a traditional data center, the processors was that a significant factor?
Of course, the traditional data center is based on x86 architecture,
Right.
normal
But that's standard across
Yeah,
everything.
that's standard across.
Yeah.
So mostly the application which are running or on a like a serialized, but you cannot do that in an HPC.
Right.
You need a parallel processing. So the number of cores in a CPU, there is a limit. Okay, so maximum you can have say 56 cores per server. When you
Right.
do hyperthreading, it will become double. Okay,
Right.
and maximum in a server you can have 2 or 4 CPUs.
Right.
Okay, together you have mostly around 200 to 300 cores.
Right.
But with a single GPU, like an NVIDIA A100, you will have like
Right.
millions of and the load is it is measured in flops, right? Like in a single NVIDIA A100 can have 362 teraflops of.
Right.
Yeah. So the more number in a server, we can have up to 8 GPUs in a single node.
Right.
So how much capacity?
Right.
So it will request more number of servers, more number of racks, and you limit the space required for you don't need that much space.
Right. Right.
And,
Because of the way the power is done,
Right.
the cooling is done, sorry, right? The way the cooling is done. Okay, cool. Yeah, that's interesting. You know your NVIDIA stuff, right?
It's expert.
Huh?
He's expert.
Expert now. Yeah. No. I think, like I said, with the libraries that NVIDIA have, if you look at those libraries even, and you look at AI product in general, whether it be gaming or that's where various companies have different AI tools. If they haven't got a GPU behind it, it does help you. It does make you question how much AI is actually involved in it.
yes.
Right? I mean, the workload. I mean, so I suppose you can run a HP. If I have a workload for HPC that might take a day, on a normal data center it might take 2 weeks.
2 weeks.
Right?
Yes.
Something on average, right? Something like that. So that doesn't make it. Does that make my? If I run it on a normal data center, does it mean you can still do AI?
Yeah, you can do it, but
It just takes too long for the processing, the parallel processing. But you can't deliver it in real time, can you? That's
Not, you are
impossible.
not utilizing the resources. Like, for example, your developers, you are not utilizing them. For example, if I have workload for 1 day, I can run it. If I can run my workload in 1 day.
Right.
So my developer can do another testing I can utilize them for something else.
Right.
Instead of waiting for the result after 1 week, how much percentage will be accurate. I'm wasting his time. I'm wasting my cost and time, of course.
Yeah.
Because developers are resources for me,
Sure.
right?
Yeah,
So
yeah.
I'm losing money.
Yeah. So running those tests is a lot
Yes.
better on HPC. No, so that'd be interesting. I think next time we should get a discussion with the developers and see, once they run some workloads, we'll have a feedback and see what how they utilize what they found new on HPC and how the software obviously interacted.
basically first time they will be running on their own laptops or their own workstation.
Right.
So what's the difference they will have once they perform it on an HPC?
Yeah.
So they can share their experience.
Yeah. And obviously anything like, say, in terms of optimization, the good thing is the experimentation side, which I guess you do experimentation on, when the apps first came out, the app stores, and they were hosted in data centers, they were all tested as containers, Kubernetes. The same processes here. I guess here the compute power is much higher. Much higher from, the compute power on apps hasn't really changed that much in the last sort of 10, 12, 15 years, whereas now being able to provide HPC on a localized environment where a student can log in and try something, or a company, you might have an IT manager who says, okay, I've got this data, the boss has asked me to do something, let me try it. Right? They can come here quite easily, especially if they're in Sharjah, and say, look, I don't know what to do, I've got the data, can you help me with this?
Yeah, so that's differentiate us.
Yeah, we have our developers who can help us. Another advantage here also, you said the data still inside the country. it's another challenge. Instead of if I'm hosting my data outside or like any other HPC provider, I don't know where is my data is located or where is my data is hosted. But here here we have local. We are doing localization for our data. Still, the data inside the country itself. It's another advantage also of our map.
Right. Oh, that's good. Yeah, I suppose also by spreading you're going from a hyperscale onto a H nodes, right? So you by distributing that, you're giving access to more compute to more people. You might be spreading obviously some of the jobs. Obviously, the cities then not dependent on a nationwide scale data center. There may be some differences in cost, but I think the HPC, the value it can extract, will pay for itself, which again probably is for another discussion another time. So no, thank you, Raneesh. Thank you, Ahmed.
Thank you.
And let's speak again soon.
Thanks so much.
Can you comment on the LinkedIn post that you shared about the data that is happening in UK?
The Palantir.
Peter, what's his name?
Yeah, Palantir.
Yeah.
I don't want Palantir to hack us though.
Like, if we have a localized data center, that doesn't happen, most likely, right? Because the data stays here.
No, it's more of a policy. I mean, in theory, Palantir could come here.
All right.
Yeah, take the space. It's more to do. So there is a level of control, right? For sure, there's a level of control which you have. Now it just depends on the government of the day. If the government on the day want to sell the citizens' data, they can. There's not much you can actually do, right? You probably can do something, but like I say, in the UK, the NHS, they've signed a deal with a company in the UK. They've signed a company with the US, and that data's going. It's $330 million or something deal. So what's happened now is that this US company, they get access to historical data without the NHS particularly benefiting from it. It's different if you make a tool from it and the NHS owns some of these tools. I don't think they're doing that. They're paying $330 million. So I think the UK government are just trying to raise money to pay for healthcare rather than thinking long term, right? So they want to get the quick sale, whatever. So what I think a good point Mark is asking is that if you're a smaller city, let's say, and you can't afford to have a hyperscale data center built in your city, and you don't want to put your information on public cloud, the edge data center, because of the space that it takes up, is ideal.
Right.
Yeah, you've got 3 racks, which is equivalent to 45 racks. You've got control temperature, plus you can do the analysis on it.
Yes.
So with the 3.5 petabytes worth of storage, which you can expand easily, right, to 10, 15 petabytes, and they're easy, right? What's one rack will hold? One rack will be...
One rack mostly will hold around 10 petabytes.
There you go, 10 petabytes, right? So I think some big corporations who are 50 years old, they have like 5 petabytes worth of data. Right, so it's easy to store. So I think the point Mark is raising, yes, there's a big advantage. If you have facility for high performance compute, you have your data scientists, you have your local storage. If someone says, "Oh, send your data over here," you don't have to. And the beauty of it is because the value of that data is so much. Yeah, healthcare data is so much. You don't have to give your asset away. You can actually have it locally and you can work on it. And a good thing with Sharjah, I think we discussed it somewhere else, with Sharjah Research Park, because it's a neutral venue within Sharjah, it's a central venue, sorry. If you have one set of data in there, it doesn't have to be just one agency looking at that data. You can just get a lot of other agencies to say, look, the data's sitting here, as long as you have the agreement with the main owner, it's within one marhead, and then you can get multiple access to it, multiple use to it. So the logic behind it is very good. So the security has to be very good. Right, but the protocols have to be there, which there's no same risk that happens with Google Cloud, right? And Microsoft Azure, they don't have their issues as well, right? So yeah, that's a good point.